We're going to continue with chapter 2 and actually finish it off today. We're going to be doing normal probability calculations or using the normal distribution, but this time we're going to be using the calculator to do all our work for us. So previously we were doing it by hand, which is important for you to know, but you can always use the calculator on the AP exam, and I'll give you some tips to make sure that you do when you're using the calculator. So how do you do normal calculations on the calculator, and what do you need to show on the exam? Well, there's two things that you can use. You're going to be going to second and vars on the calculator. Let me scroll back down. Sorry. Okay. So we're going to be going to second and vars on the calculator. And under second and vars, there's two options. We're going to be using NormalCDF or inverse norm, depending on what the question is asking us. CDF stands for cumulative density function. So we use NormalCDF when we're asked the questions about what proportion of values are between this and this, what's the probability. So NormalCDF gives us the proportion or the probability. When you go to NormalCDF on your calculator, it's going to ask you to plug in several things. It's going to ask you for the lower bound, the upper bound, mu, which is your mean, and sigma, which is your standard deviation. It's important that you're labeling all of these things on the calculator when you're doing this. The other option that we have is we have what's called inverse norm. Sorry. So we have inverse norm as well. And inverse norm gives the value at a given percentile. So this is when they say, okay, what value is at the 30th percentile or the 75th percentile? In those cases, then you use inverse norm. When you go to inverse norm, it's going to ask you for the area. That area is the area below or the percentile. So for example, if they say what value is at the top 10%, you would not plug in 0.10 as the area. You would plug in 0.90 because 90% is below the top 10%. It's also going to ask you for mu and sigma as well. The most important thing when you're dealing with any of these types of problems is you must label everything. And you have to write NormalCDF or inverse norm. So you can't just give me the answer. You have to write NormalCDF, lower bound, upper bound, mean, standard deviation. All of that stuff has to be written as a part of your answer. In addition, my suggestion is it's always a good idea to draw the curve. Even if you just make a quick sketch of the curve, it's always important that you're doing that to have an idea of what area you're finding or what value you're finding the percentile for. Okay, so draw the curves in, even if it's a quick sketch. So let's take a look at how we solve these problems. I'm just going to go through the first three examples here. So suppose Clayton Kershaw of the Los Angeles Dodgers throws his fastball with a mean velocity of 94 miles per hour and a standard deviation of 2 miles per hour. The distribution of his fastballs can be modeled by a normal distribution. So it's important that we're only using these things when things are told to us that they're normally distributed. So let's draw in a quick sketch. 94 is here. I know the standard deviation is 2. And I'm looking for at least 100. So I'm looking for this tiny area right in here. Now, could I do this by hand? Sure, I definitely could. I could find the z-score 100 minus 94 over 2, get a z-score of 3, look it up in our table, our standard normal table, then do 1 minus that. But you'll see that this is a lot quicker method than doing it that way. Could you do it by that method? Sure. Should you know how to? Absolutely. But you can definitely use the calculator. So on the calculator, we're going to go to NormalCDF, because in this case, we're asked for a proportion that is at least 100 miles per hour. And it's going to ask us for several things. It's going to ask us for a lower bound, an upper bound, the mean, mu, and the standard deviation, sigma. So it's important that you label, like I've just done, and written out everything that you're dealing with. At least 100 miles per hour means, looking at my picture, which helps out, the lower bound, the lowest value that I care about is 100 miles per hour. The upper bound, technically I'm going from 100 to infinity, anything above 100 miles per hour. I can't put infinity in the calculator, so I'm just going to put a really big number, 999999999. Okay? Again, technically we're going to infinity, but I can't put that in. The mean for this particular problem is 94, and the standard deviation is 2. So I'm going to go to my calculator now, and I'm going to go to second and vars. Notice in blue it's distributions, because that's what we're talking about, a normal distribution. There's lots of different types. NormalPDF is something that we will never use. We're only using these two, NormalCDF and inverse norm. So I'm going to go to NormalCDF here, and I'm going to plug in my values. My lower bound is 100. My upper bound, really big number. Mean is 94. Standard deviation is 2. And I'll go down and hit paste. So hit enter, and hit enter again. And it'll get me my answer of 0.0013. Now, again, like I said, could you have done it by hand? Sure, but why do it by hand when we have access to the calculator at all times? So as a part of your answer, you need to include both, what's in both boxes there, what you've entered into the calculator, as well as your final answer. Let's look at another example about what proportion of his fastballs will travel between 93 and 95 miles an hour. Let's draw in a quick sketch. Mean is here, 94. I'm looking for this middle value here, this area in here, okay? NormalCDF, because again, I'm looking for a proportion in between values. Lower bound here would be 93, upper bound 95, the mean is still the same mean of 94, and our standard deviation is the same standard deviation of 2. Could I do it by hand? Sure, I could. I could find both z-scores, look in my standard normal table, subtract the proportions, but let's use the calculator. Second and vars, down to NormalCDF. Lower bound is 93. Upper bound is 95. The mean and the standard deviation are the same. Enter, enter, and I'll get my answer of 0.383. It is crucial that you include this part. If you just have an answer of 0.383, and the curve as well, if you just have an answer of 0.383 with no work, you will not receive any credit. You have to show work. Next question, C. What is the 30th percentile of Kershaw's distribution of fastball velocities? So here we're not asking for a proportion in between values or above or below a certain value. We're asking for what is the value at a given percentile. In this case, this is where we would use inverse norm. Again, I'm going to draw in a picture. I know 94 is here, and I'm looking for this mystery value in which the area below is 0.30, because remember what the definition of a percentile is, the percentage at or below a given value. So could I do this by hand? Absolutely. I could look up what z-score corresponds to the 30th percentile and then solve for x. Why do that when we could just use the calculator and inverse norm? So I'm going to go to inverse norm on my calculator. The area represents the area below, so in this case it would be 0.30. The mean is 94, and the standard deviation is 2. So on my calculator, same spot, second, and vars. This time we're using inverse norm. Area would be 0.3. Mean 94. Standard deviation is 2. Enter, enter, and I'll get my value that's at the 30th percentile, which is 92.95 miles per hour. So again, make sure that you include both parts. You include your answer as well as what's been plugged into the calculator. I encourage you to use the calculator, okay? Especially when you have free response questions and things like that. You certainly can use the calculator to do that. Just make sure that you're labeling everything and you're drawing in a quick sketch of the curve that you're using. We'll look at questions D and E in class. If you want to try them at home, feel free, as well as our final question in the notes that's talking about how you find if data is normally distributed. Good luck, guys. We'll do plenty of examples in class, and I'll see you then.